Hi, this is Zixuan Jia. So the first question asks, what is the worst possible insertion order for 10 strings, each 3 characters long, into a ternary search tree? Okay, so the worst case should be like for 30 characters, like no characters are repeated. So when you inserted characters in this tree, like every time it creates a new vertical row, so it will look like this. So the height of it will be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is why this one is 11. Okay, so for the second one, into binary search tree, the worst possible insertion order will be like for every node, it will only have one child. So this one is like one of the worst cases of binary search tree. So the height of this one is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this one is 9. Okay, so for question 1, what is height to the corresponding 2 to 3 tree? So I draw the 2 to 3 tree, and we can easily see that the height is 2. Okay, so for next question, at least how many values do you need to add to the corresponding 2 to 3 tree in order to cause a height increase? So for this one, I drew the process of like adding components. Firstly, we add one node here, and we know that this node will like go to the top like this. And then we add two nodes here, add two values like here. And then the middle one will also go to the top. So it will look like this. And then we notice that here we also have a like 3-value node. And this one will also go to the top. And then here will look like this. Okay, so here we also have a like 3-value node. This one also goes to the top. So finally we reach this like height 3 tree. And totally we add 3 values. Therefore the final result is 3. Okay, so for this question, at most, how many values can you add to the corresponding 2 to 3 tree without causing a height increase? Okay, so we know that for a height 2 to 3 tree, the most values we can add to it is 26. So we know that for each node we have like maximally 2 values in it, and it will like maximally have 3 childs. So for first level, it will store 2 values. Second level, it can store 6 values. And for third level, it can store 18 values. So these add up to 26. And then we minus 12, which is the values like the tree originally have. And then we get 14 is the answer to this question. For question 4, at least how many values do you need to add to the LLRB tree in order to cause the height increase? This one is just quite easy. We can just simply like add a node here, and then it will like increase its height. Okay, so for this question, so when I add a node here, we know that the red link will like should lean to the left but not right. So like we should do some rotation with it. So we can see that we need to rotate this node to the left in order to do that. So it will look like this. Therefore, we choose the second one, because like every time our B tree adds a value, it will firstly like add a red edged leaf. So then we cross out these two black ones, and then this one is the new leaf's parent node. So like this one is the correct one, and that's it.